Hello everyone. Today I'm going to be talking about Myron Scholes. Myron Scholes was a mathematician born in Ontario, Canada in 1941. He is important because of his contributions to today's stock market. Scholes and his accomplice, Fisher Black, created the Black and Scholes formula in 1973. This was a monumental new method of being able to reliably price and predict the prices of option stocks. Scholes received the Nobel Prize in Economics in 1997. However, Black did not receive the award because he unfortunately died of throat cancer. Scholes began his academic career teaching at MIT from 1968 to 1973, where he decided to study at the University of Chicago. It was here that he pioneered his groundbreaking formula. He later went on to become a professor at Stanford Law and Finance. The reason the formula is so monumental is because before its development, traders had no way to reliably price option stocks, or in layman's term, a stock that acts as insurance that can be bought and sold on various equities. The key idea behind the model is to hedge the option. By buying and selling the underlying asset in just the right way, you can in consequence eliminate risk. His formula was later expanded upon for other areas of finance, such as home mortgages and risk management in general. Scholl's formula is still widely used today. He made the formula using statistics and derivative investment instruments. Due to his fluency in statistics, he was able to apply the theories of probability and data analysis into a formula that could be reliably applied. This is according to the Britannica Encyclopedia, the Free Social Encyclopedia, and the University of Stanford. As a pioneer in his field, he opened the door for thousands of new jobs and eventually created the Wall Street that we know today. Let's meet a modern day data scientist, Casey Worthington. He is the top quantitative data analysis or quant at my dad's hedge fund, Headlands Technologies.
uh, Start with degrees. Yeah, most people have at least a bachelor's in something quantitative, so math or physics or computer science or engineering. Uh, Probably computer science is the most common. But yeah, anything where you kind of know how to both program and have some statistical intuition is is there. A lot of people have PhDs, but it's not really required. I wouldn't say even. I mean, there's a few people in the industry without college degrees, but that's pretty
It's
rare.
just
Like,
skill, yeah.
yeah, if someone started a company or something, like we wouldn't hire anybody out of high school. And certificates, there's not really certificates that would really be considered useful. I guess if you were a software engineer and you got a certificate in like math or something from a university, that would maybe help. Um,
Now, where did you go to college?
Cornell.
Cornell, nice. Did you major in comp sci there?
I was electrical engineering.
Electrical engineering. When did you start comp sci or like just data analysis in general?
Well, you took a few programming classes and electrical engineering, so that was kind of where. And then data analysis. I didn't take any machine learning classes, or but there's some statistics classes that are required, and electrical engineering has a lot of like probability based things. So there's like a good amount of overlap between CS and electrical engineering.
So, what's like the typical salary range of a data analysis on the stock market and just in Wall Street today?
It varies widely at like top trading firms. People coming out of college probably are getting like 2 to 300,000 now. Um, like lower tier firms, it's probably still like 100,000 like ish. Um, if you go down the list, there's probably some people making less than that, but not too many.
Hmm.
And then, yeah, kind of the sky's the limit. Uh,
Now, like what's the demand for this position today in on Wall Street and just in general, like any data analysis?
I think it's very high.
So, what specific skills are companies looking for in data analysis? How people stand out over others, and like what makes a good data analyst good?
The main two things are uh, computer programming and good quantitative intuition, I guess, understanding of statistics at an intuitive level, I would say, where you kind of actually really know what's going on. Like it's different than just doing the math, being able to kind of like interpret. A
Mm,
lot of it's results that aren't necessarily clear one way or the other, and you have to have kind of a good understanding, like holistically.
mm-hmm. So, what programming languages are you fluent in? And like, what do you use most?
At Headlands, we use mostly Java and C++. So those are the two. The most popular in the industry are probably Python and C++. Java is less popular.
What makes C++ so appealing for data analysis?
Uh, I think, like you said, we prefer Java or C++ because the structure of it is lends itself that like the structure of it aids in constructing large software projects that a lot of people will work on. So, like you said, Python is very easy to write, but it's relatively brittle. It's not nearly as fast when you're running it. And then if you have like a giant Python code base, it can get pretty
Mhm.
hard to understand much more quickly, kind of because it's so easy to
It's pretty
write.
hacky. Yeah, you can write it pretty fast. Yeah.
Right.
Um, so like I've looked on the Headlands website, and for like the application, it's like write a program in C++ returns like a square root of 42. Um, how does fluency in mathematics help data analysts and like programmers in their field of study or just in their career in general?
Um, well, programmers, because computer science is pretty mathematical, I guess. Like just the like algorithmic thinking
Mm-hmm.
algorithmically is a kind of subfield of math. And then for data analyst data analysis, it um, yeah, like I said, it's just kind of the whole point is finding finding meaning in data, and so to do that, you have to both be able to just run some like statistical tests on it or machine learning algorithm, but then not only just be able to run it, be able to interpret the result. And to interpret the result, it's like statistics is pretty counterintuitive. Like there's a lot of paradoxes